let's move to the keynote address by John Kerry. So the keynote title is so Advancing HPC Together. So yeah, please start.
Are you able to see my slides?
Yes, of
Showing it?
course.
Okay, perfect. All right, great. So thank you so much. Thank you, Professor Boku. First and foremost, I want to thank you for this opportunity to speak to all of you today. As I was telling Professor Boku early on, because I logged in a little early, I wish I was doing this in person, especially since it was to be held in the beautiful Jeju Island in South Korea. I was born in South Korea and immigrated to the United States when I was 9 years old. When I graduated from UCLA, I visited South Korea in 1994, and I had an opportunity to visit the beautiful island at that time. So hopefully, very soon, I will have another opportunity to go there. So for those of you that don't know who I am, my name is John Lee. I am the Senior Director at Intel. I work for Trish Damkroger, VP and GM for High Performance Computing. I'm responsible for the business and platform strategy. In that role, I have a team that is responsible for setting and implementing Intel's HPC business strategy, as well as our HPC product and platform strategy. So I joined Intel a little over 5 years ago. And prior to that, I was at Cray. I was responsible for their cluster product line. And I came to Cray through the Cray's acquisition of a company called Apro back in 2012. I'm sure some of you, I know Professor Boku, he and I have known each other for over 10 years when I was at Apro, and we delivered some of the supercomputers to University of Tsukuba. And at Apro, I was responsible for product development and manufacturing. So I have been in HPC for approximately 20 years, and during that time, I've had the enormous honor and opportunity to work with many of the premier HPC supercomputing centers throughout the world. I've had the pleasure to meet and work with Professor Boku, Professor Sato, and Professor Nakashima of Kyoto University, as well as many of the some of the engineers I think from KISTI I probably have met because I visited KISTI many times. I was hoping somebody from ETRI would be here too, but it looks like ETRI is perhaps is not a member of XPUG. But anyway, as I was looking at the workshop agenda for today, I realized that it was packed with a lot of technical sessions. So for today's keynote, I figured I would be talking about business and kind of Intel's HPC strategy. Okay, so I wanted to share with you Intel's vision for the future of high performance computing. Okay, we are seeing some seismic shifts in the industry due to the global race to the exascale, emergence of artificial intelligence, and accelerated migration of HPC workloads to the cloud. As our industry kind of grapples with these challenges and opportunities, Intel's vision for the future is one of advancing HPC together. Okay, as one of the leading companies in this industry, I believe there is a sense of responsibility to continue to contribute back to the community, to build a healthy ecosystem, and to build a strong future together. Okay, so let's get started. Today, we're living in a rapidly changing world. We only need to turn on the TV or just step outside of our home to see that. COVID has changed almost every aspect of our lives, how we work, how we go to school, how we socialize, and how we entertain ourselves. Everything has changed. The criticality of time to insight has never been more urgent than today's COVID world. It literally is a matter of life and death. In fact, just this week, United States passed a grim milestone. We had over 400,000 deaths. That's more than the lives lost in World War II due to this virus. To pay his respects, our new president, Joe Biden, before he was inaugurated, held a memorial ceremony at the Lincoln Memorial for all the Americans lost, lives lost. We mourn all the lives lost across the globe. So we are witnessing the importance of accelerating the time to insight in medicine to combat this disease. But the problems of the world does not stop there. Accelerating time to insight in finding cleaner energy sources to save the planet has never been more urgent. And improved time to insight to more accurately predict the weather patterns to detect natural disasters like hurricanes and forest fires can save countless lives as well. And the key to time to insight will be our ability to compute and process vast amounts of collected data, both qualitative and quantitative, and in turn, that data into insights and predictions so that correct actions can be taken to save lives. Just to put some raw numbers into perspective, there was a data study released by an organization called Raconteur. They are a digital publishing firm back in April of 2019. They reported that over 463 exabytes of data will be created every single day by 2025. And IDC, a global market intelligence firm, predicts that with rapid growth of data centers around the world and exponential growth of the edge and IoT devices, that the global data sphere will grow from 45 zettabytes in 2019 to over 175 zettabytes in 2025. Okay? So I know that these are astronomical numbers and some of us may be a little bit skeptical, but if you do a quick reality check, just look around your home and see how many connected smart devices you have. I have a Wi-Fi router at home, and when I checked to see how many devices were connected to it, I noticed that I had over 45 smart devices, all by my lonesome. Laptops, cell phones, security cameras, and doorbell, you name it. And suddenly, this astronomical numbers don't seem all that big. Okay? And what is amazing is that high performance computing is at the heart of solving these grand challenge problems. I'm sure many of you are like me. I feel incredibly blessed to be part of the HPC community, to be surrounded by so many talented and brilliant people tackling the most complex and challenging problems of our time. Of course, this isn't a new problem for high performance computing. As I told you, I've been in this industry for about 20 years. Our community has been trying to accelerate time to insight for decades. And our industry has been leading the charge in improving system performance to be able to tackle greater and more complex problems. So what has changed? So what I believe has changed is the speed with which the world is changing all around us. Pace of change is accelerating. I want to draw your attention to the quote below by Canadian Prime Minister Justin Trudeau. He says, "The pace of change has never been this fast, yet it will never be this slow again." The irony in this quote always brings a smile to my face because I think it captures the time we're living in very, very well. It seems like a long time ago, but it was only 2 years ago, I think. I was getting ready to go to work. I got in my car, and my phone automatically told me that I should be at work in about 30 minutes because the traffic was pretty light. Now, I didn't ask my phone to take me to work. It just automatically guessed based on the time of day and my past behavior pattern that I must be going to work. So what it did was it opened up my GPS by itself, analyzed the traffic, picked out the most efficient route, and told me. At that time, I just remember being kind of stunned because it was the first time that happened, and a little concerned about my privacy. And what is fueling this rapid change is technology. Technology powered by high performance computing. Now, as we look around our industry today, there are three, I think, key factors that are accelerating the growth of high performance computing. One is global race to exascale, artificial intelligence and increasing convergence of HPC with AI, and HPC workload that are migrating rapidly to the cloud. So global race to exascale is this generation's space race of the 20th century. There is an incredible amount of investments being spent by the governments to be the very first. Obviously, Intel has a horse in this race, but I am more excited about the technological advancements that will come out of this race. Recently, Intel and US Department of Energy announced our commitment to delivering Aurora Exascale supercomputer at the DOE Argonne National Lab in 2022. Once completed and in production, amazing advancements in science will be completed in the areas of medicine, weather, climate, and material science. Okay? Now, we know similar collaborations are happening throughout the world. In Europe, through the EPI initiatives, and in Asia as well, in China and Japan, and I know Korea and India. Now, according to Hyperion, it is this substantial government investment in Exascale that is making the high-end HPC, the supercomputing segment, the fastest growing segment for the next several years. Now, the second factor that is driving accelerated growth in HPC is the emergence of artificial intelligence. Okay? Now, if you squint your eyes, the two systems look very, very similar because they fundamentally have the same high performance infrastructure. System architecture and configurations are very much alike. High-powered processors and/or accelerators with high-speed memory connected together by low-latency interconnect. Now, in 2018, Professor Satoshi Matsuoka of Tokyo Institute of Technology and director at RIKEN, in a talk, stated that, quote unquote, modern AI is enabled by supercomputing. Okay? Now, the third factor is accelerated migration of HPC workloads to the cloud. Here I am referring to the public cloud computing. Hyperion declared that 2019 was the tipping point for HPC in the cloud. HPC cloud spending in 2019 was almost $4 billion, forecasted to grow to almost $9 billion by 2024. Now, CAGR, which is a cumulative aggregate growth rate, for HPC cloud is almost 2.5 times the growth of traditional on-prem HPC over the same horizon. So what is driving this growth? Now, there are many reasons why users would run to the cloud. Convenience, lower cost if their system utilization is sparse, and access to more advanced capabilities and/or choice. Now, also interesting is that unlike the on-prem HPC business, the key segments that are driving the growth for HPC in the cloud is the work group, not the supercomputing. And the vertical segments are biosciences and CAE, not government nor academia. Okay? Now, we at Intel, we've done a lot of testing in the cloud, and it is still more difficult to run large-scale jobs in the cloud than on-prem, but things are rapidly improving. As more and more of these barriers are removed, we expect growth in HPC or growth of HPC in the cloud will only accelerate faster. Now, what I'm most excited about with HPC in the cloud is my belief that as it becomes easier to run HPC workloads in the cloud and scale, it will expand the overall HPC market. History has proven over and over that when complexity is simplified or eliminated completely, adoption accelerates. So when more and more users take advantage of HPC technologies in the cloud and are able to monetize its benefits, we will see an explosion of new users joining our community. Now, all of these factors combined, race to exascale, HPC being infused with AI, and accelerated migration of HPC workloads to the cloud, they are what's accelerating the growth of high-performance computing today. Now, of these factors, we know that the exascale systems will usher in a new class of capabilities systems. Some of its innovative technologies will waterfall down to the rest of the HPC market, and some will not. And HPC in the cloud will expand our markets to new users as well as enable existing users to augment and/or change the way they consume HPC compute cycles today. But HPCAI Convergence can dramatically change HPC altogether. So let's dig into that a little more deeply. So earlier I indicated that HPC and AI share a common need for a high-performance infrastructure to run their respective workloads. They both need lots of computing power. More you throw at them, the faster you will get results. They both benefit from accelerators and high-speed, low-latency interconnect. But beyond converging on a common high-performance infrastructure, there is convergence happening at the workload level as well. So for instance, we're seeing AI being integrated into HPC workloads to accelerate things like pattern detection to speed up drug discovery. So Intel partnered with a company called Novartis to apply deep neural network acceleration techniques to process large image data sets faster while extracting greater insight. Now, in certain cases, AI has the potential to replace physics-based models altogether. So Intel collaborated with CERN to demonstrate that AI-based models have the potential to act as significantly faster alternative to a computationally more expensive physics simulation while maintaining remarkable levels of accuracy. So speeding up the most time-consuming simulation tasks can dramatically increase system efficiency and make the systems more productive. So Professor Matsuoka spoke about convergence of HPC and AI as the following three things: acceleration of simulation with AI, AI replacing simulation, and acceleration of AI with HPC. So I cover the first two with Novartis and CERN examples. Now, regarding the third about acceleration of AI with HPC, Professor Matsuoka was stating that it isn't just HPC that benefit from AI. HPC can accelerate AI via data cleansing and by applying advanced HPC networking techniques to scale to bigger training sets. In essence, the convergence of HPC and AI results in mutual benefits. Now, while we're still in relatively early stages of HPC and AI convergence. However, we're seeing it proliferate across a broad range of industries with a broad set of workloads. The primary goal of applying or integrating AI into these existing workloads is simple, however, and that is to accelerate and enhance insights. That has traditionally been done only by HPC. Now, this phenomenon raises a fundamental question about what is the future architecture of HPC systems look like? So Intel XPU strategy is Intel's answer to that question. Our strategy is to bring a diverse mix of scalar, vector, spatial, and matrix architectures to address the unique needs of our customers and their workloads. Intel has made significant investments to build the most flexible and performance-optimized portfolio of compute products. Now, starting with our general purpose Xeons to XeGPUs, Stratix FPGAs, and specialized accelerators such as Habana, Movidius, and Mobileye. And our portfolio of compute processors are supported by, and this is the most critical piece, an open industry standard programming model that is unified to simplify application development and cross-architecture portability. Now, Joe Curley, who's a peer of mine, will be coming in later to talk specifically about oneAPI. Okay, I ask all of you guys to make sure you tune in and listen to him because it's super exciting stuff that we're doing with oneAPI. Now, what I just said is the promise of oneAPI. It's to build a common platform to enable seamless heterogeneous acceleration. Now, at Intel, it begins, as always, with Intel Xeon processors. If we could make everything run best on Intel Xeon, we would. But of course, there is a legacy penalty you pay for being a general purpose processor. So you get the good with the bad. But for the vast majority of our customers, we believe Intel Xeon remains the workhorse for HPC and AI workloads. However, as demand for highly parallel throughput computing continues to grow, there is a need to complement Xeon with GPU accelerators. Argonne's Aurora system is a perfect example of that. There, the Intel Xe architecture-based GPUs are built to target users whose applications demand optimizations for highly parallel HPC applications, as well as deep learning training. Now, and for these customers that require even more flexible compute architecture, we offer our Stratix FPGAs, our spatial accelerators. Combined with our low-power Movidius VPUs for edge applications, Intel offers the most comprehensive portfolio of compute products for HPC and AI that is unmatched. So at the heart of our XPU strategy is Intel's XeonScalable processor. So we continue making incremental improvements and enhancements to make Xeon the only data center CPU optimized for the convergence of HPC and AI. So Cascade Lake that is shipping today has a built-in HPC acceleration with AVX512 and built-in AI inference acceleration with DL Boost. And I know it doesn't get a lot of attention, but our Cascade Lake advanced performance processors with up to 56 cores and 12 memory channels offer the highest memory bandwidth than any other x86 CPU in the market today. And that would include Ice Lake that's coming out later this year. Now, Cascade Lake Scalable Performance Processor, on the other hand, was also the first generation of Xeon to introduce Intel Optane persistent memory technology. And that was to accelerate data analytics and AI applications. Now, this was the key technology that made DAOs possible, where we use PMEM memory as high-speed storage to power the storage subsystem for the Aurora supercomputer. And this year, we will begin shipping Ice Lake, followed by Sapphire Rapids, with continued improvements in both HPC and AI acceleration performance to maintain its position as the only CPU optimized for convergence. And to be honest with you, as excited as I am about Ice Lake that's coming out very shortly, I'm even more excited about our future Sapphire Rapids and look forward to sharing more news with you under NDA because this is under CNDA. And for those customers that do not need dedicated AI accelerators via GPUs, Intel's Xeon scalable processors continue to be the foundational workhorse for all your HPC and AI applications. So let's dig a bit deeper into Ice Lake that's coming out. This Ice Lake is our third generation Xeon scalable processor. Ice Lake with its Sunny Cove enhanced core will deliver advanced performance across a range of HPC workloads this year. Ice Lake has 8 memory channels operating at 32 megahertz speed to provide higher memory bandwidth, which is critical to many of our HPC applications. And with the new microarchitecture, our customers will see up to about 18% improved performance per core. Ice Lake will also be our first processor with PCI Express Gen 4 bus for high-speed I/O support. Now, in addition to the new microarchitecture, Ice Lake will support next-generation Intel Optane persistent memory for improved performance there as well. Now, all of these improvements combined with some impressive leadership performance across a diverse set of HPC workloads that you see here. More details will be made available closer to launch, but as you can see, what we're able to disclose is still pretty impressive. What is even more impressive is that we achieved these results with half the cores versus comp, 32 cores versus 64 cores on the AMD side. Now, we're seeing these results on key life science and financial service applications such as LAMPS, NAMD, and Monte Carlo. Now, continuing with Ice Lake, at Supercomputing 2020, we announced that Korea Meteorological Administration, or KMA, selected Ice Lake to power their next generation supercomputer. This supercomputer will deliver theoretical peak performance of approximately 50 petaflops, which is 8 times faster than their current system. This machine will be powering weather and climate studies to deliver more accurate, reliable, actionable forecasting. I look forward to seeing the system powered up and going into production this year. Now, in addition, Max Planck Computing and Data Facility, located in Europe, also selected Ice Lake for their new system called Raven, which will double the performance of their current existing system. That system will be enabling groundbreaking research in multiple science disciplines. And finally, Oracle Cloud Infrastructure will be leveraging the computing performance of Ice Lake in their next generation instances. And when testing early samples, they saw up to 30% performance increase on CFD and EDA workloads. Now, these are all amazing results, and we look forward to sharing even more information with you closer to launch. So let's switch from our Xeon to our Xe GPUs. So back in 2019 at Supercomputing Show during DevCon, Raja Kaduri, our senior VP, announced our Xe architecture. Since then, we have made steady progress and have released more information around our GPU family of products. Now, Xe is a key part of our overall XPU strategy to augment the strong CPU, FPGA, and other accelerator businesses with a powerful family of GPU products. Xe is a scalable, modular architecture that allows us to scale from teraflops to petaflops. It is purposefully built, scalable architecture designed with flexibility to address many different markets, spanning from integrated graphics and discrete entry to mid-range to enthusiast markets, all the way up to data center AI and HPC Exascale. The ones that are targeted for commercial HPC and AI are XeHP and XeHPC product lines. Now, the XeHPC, I know it's a lot of acronyms, is the architecture behind the compute accelerator, codenamed Ponte Vecchio, that was designed into power our Aurora Exascale supercomputer. Our first commercial XC products will be shipping later this year. So we believe with the XC GPU family of products added, Intel will have a very comprehensive data center product portfolio that will be unmatched in the industry. Like Ice Lake and Sapphire Rapids, stay tuned to hear more disclosures about our XC HPC product line at ISC 2021, and then even more information at Supercomputing 2021. So powering all of our XPU product lines will be one API. Now, I'm not going to steal Joe's thunder here. I'm not going to talk too much. I have 3 slides on this. I'm sure he's going to have more, and he'll be able to go into even more details than I can. But one API is the glue that brings all of our XPU strategy to life. One API is not a dedicated programming model for Intel GPUs only. Far from it. One API is an open, unified programming model built on standards to simplify development and deployment of data-centric workloads across CPUs, GPUs, FPGAs, and other accelerators. Now, there are layers in a software stack. The picture on the right is kind of rather rudimentary. It's kind of an oversimplification. But for this discussion, I think it's going to be fine. At the top of the stack are applications and workloads where data scientists and other developers typically like to operate. They utilize middleware and frameworks like TensorFlow and PyTorch, as well as other high-level languages like Python and Julia. Then there are lower-level languages that HPC users like to use, developers, Fortran and C++. Now, and the layers of abstraction of the software stack allow for easy reuse and ability to bring those capabilities quickly to market. And where one API is at this lower level of the stack that fits underneath the middleware and frameworks. So that we can code that is already running on CPUs and quickly bring that to other architectures with very minimal, if any, code changes for those that live at the highest level of the stack. Now, this allows us to deliver through one API a cross-architecture programming model that delivers freedom of choice. What does freedom of choice mean? Okay. Freedom of choice from the economic and technical burdens of proprietary programming. Proprietary programming models that support accelerated computing today. Now, we accomplish this by exposing the latest cutting-edge features of the target hardware technology, expose that through the stack. But we do this while building upon, not replacing, the existing HPC programming models such as OpenMP, Fortran, and MPI. And most importantly, this is based on industry standards and open specification so that any vendor or any contributor, not just Intel, can implement the same capabilities and contribute those back to the developer community. This is a very important point to make and why I said one API is the glue in making Intel's XPU strategy successful. Intel has been and continues to be a champion of standards and open specifications. We believe proprietary solutions stifle innovation and slow down progress. History has shown that when done right, standards accelerate adoption and fuel innovation. Great examples of this are PCI Express bus, universal serial bus specifications. So we have been working on one API for a few years now inside Intel, and we officially announced our plans at 2019 Supercomputing DevCon. Our announcement at the time included the industry initiative, the beta version of our product, as well as our dev cloud. And the team has been working furiously inside Intel as well as with our ecosystem partners in the spirit of togetherness to strengthen our specification and the overall initiative. In September of last year, the One API team released the One API 1.0 specification. And in between the beta and the 1.0, the team had numerous interim releases in support of the ecosystem to add more features and to support a broader set of architectures. But I think the team's greatest accomplishment and excitement has been around the overall ecosystem engagement, which has been fantastic. Not just in providing us feedback, which we value, we absolutely value the feedback, but also making significant contributions. For instance, as you could see there, CodePlay launched Data Parallel C++ compiler for NVIDIA GPUs. And University of Heidelberg signed up to be the center of excellence to bring the same type of support for AMD GPUs, showing that one API, that this is indeed an industry-wide effort and cross-vendor support. And in December of last year, so that was less than a month ago, right? The team, the One API team met their goal with the release of their gold version of the One API toolkits, which was a huge milestone because it was the first substantiation of the productization of the specification. All of the team's efforts were built upon the heritage of our proven HPC tools, such as Parallel Studio XE, compilers, libraries, analyst tools. And we expanded these capabilities across the entire XPU spectrum. And the best news of all to the developer community is that all of this is available for free. You can run One API locally on your machine, or better yet, within our dev cloud. Now, speaking of dev cloud, it is already delivering on the promise of no downloads, no hardware acquisition, no installation or setup. Today, over 3,000 developers are currently active in the dev cloud. And since this is a Intel users group workshop, I wanted to highlight how important dev cloud is and invite all of you to log in and take it out for a test drive. Especially now, since many of us are working from home, and with dev cloud, you can access new hardware properly configured without any hassles and be productive right away. And this developer sandbox has support for our Xeon CPUs and our FPGAs. And there are even more good news because Intel Iris Xe Max, which is publicly accessible, and Xe HP is also available to the early access developers. Now, in addition to being available in the dev cloud, samples of both Iris Xe Max and Xe HP are already at Argonne Labs and are being used as a development vehicle for Aurora. So with all of this ecosystem engagement, we're very excited about the opportunities that One API delivers for the developers and the ecosystem. Okay, that was a little slow. So in addition to making great processors, the other thing that I think Intel has historically done very well, in my opinion, is to build out an unmatched ecosystem. We have decades of experience in ecosystem engagement and the work we have done, as well as the work we continue to do with our independent software vendors, cloud service providers, open source applications, and AI frameworks. Now, all of these translate to, at the end of the day, better overall application performance. The gap to bridge between the hardware capability and realized application performance is vast, okay? And it is done through really hard work. Intel has a long proven history of doing that heavy lift, and we look forward to continuing to partner with our ecosystem partners to do just that. Now, not many people know this, but Intel is the #1 contributor to the Linux kernel. We contribute over 500,000 lines of code modification each year. And for a company that is known as a hardware company, we have over 15,000 software engineers. It is this breadth of ecosystem engagement and contributions that I think make Intel special. Okay. So the title of my talk today was Advancing HPC Together. So I began by sharing with all of you about the incredible pace of change that we are seeing and how HPC is at the center of it all, powering and fueling that change. I also spoke about the great opportunities with race to Exascale, HPCAI Convergence, and the accelerated HPC workload migration to the cloud. And finally, I shared Intel's XPU strategy and One API, and how One API is that key, that glue to bring all of our compute architectures together: scalar, vector, matrix, and spatial architectures, all unified by a single software abstraction. And I reiterated that Intel's commitment to standards and open specifications, because we believe proprietary programming models stifle innovation. So Intel is committed to that architecture vision by investing in leadership process technology and advanced packaging capability, building diverse compute architectures that will deliver the highest performance for all your diverse workloads, re-architecting the memory and storage hierarchy to deliver the bandwidth, and the memory capacity that your application needs, and game-changing interconnect technologies. And I know I didn't spend a lot of time on interconnect technologies, and you're probably thinking like, hey, didn't you guys just get out of the OPA business? That is true. We did divest from the OPA business, but we didn't just shut it down. We spun it out as an independent company, and now it is Cornelis Networks. And Cornelis Network is now able to sell and to bring high-performance networking, not just Intel architecture, but all architectures that are available in the market. Where Intel is investing related to interconnect technologies are in the areas of high-performance Ethernet, both on the NIC side as well as the switch with the acquisition and investment that we made to Barefoot, and that we continue to invest in our optical I/O technologies. Okay. So in addition to game-changing interconnect technologies, the other thing that I forgot is CXL. CXL is kind of a continuation of what I talked about with standards and having open specifications. So we saw a gap because in the modern HPC supercomputer, and especially a converged supercomputer architecture, where you need to connect multiple accelerators together, the scale up interconnect is going to be just as important as a scale out networking. And CXL was our way of bringing a standard and a specification body so that everybody's accelerators will be able to connect with one another in a standard way and be able to have the high bandwidth, low latency connect between the host processors and the accelerators. The other thing that I didn't talk about that Intel is very passionate about is in the areas of security. So we're going to continue to implement security technologies at every level. And finally, and I think I've highlighted this multiple times, the glue that keeps everything together, and that is our unified programming model for the heterogeneous systems of today as well as tomorrow. But all of these, we can't do it alone. Not Intel, not anybody. No one can do this alone. Now, in order to advance HPC forward, we must do it together. So at this time, I'd like to thank all of you for inviting me. And if anybody has any questions, I'll be happy to take the questions.
Okay, thank you very much. Great talk. And so if you have any questions, so please type in the chat window of Zoom, or please say directly, so without a mute. Any questions?
Hopefully, I didn't talk too fast. I was trying to pace myself.
Okay, so so I'm very curious about the interconnect.
Yes.
So you mentioned OPM team was spin out from Intel, and but Intel yourself developing Ethernet based interconnect.
Yes.
So so actually Intel's strategy will be the standard in Ethernet with HPC function.
Yes.
Is that right?
So yeah, Hanawa-san, that's very true. And I think this is consistent with what I was talking about in my presentation, that Intel is very committed to the standards and open specifications. As you know, OPA was a proprietary technology, and we made a business decision that was a market that Intel was not going to organically invest in. That doesn't mean that that's not an attractive market. It is an important market, but Intel can't invest in every place. So what we decided to do was we decided to shift our interconnect strategy to standards-based Ethernet. And right now, for high-performance computing, what we plan to do is, as we come out with higher performance Ethernet down the line, you're going to see us start to pull in some high-performance computing features like tail latency, making sure that we have QoS, that we lower the latency, overall latency through other means. So you're going to start to see more and more of that. But yes, our long-term strategy for high-performance interconnect is going to be on standards-based Ethernet with HPC features and capability. At the same time, we work very closely with Phil Murphy, who's the new CEO of Cornelis Networks, and the team that's there. Because we think they're a really strong interconnect partner that Intel can partner with. Because the problem with the Mellanox is that Mellanox has been acquired by NVIDIA, right? So there's a little bit of a situation there. So I think having a third-party independent high-performance fabric player like a Cornelis, I think is a good thing for high-performance computing industry as a whole.
Thank you. So,
may I have a question?
Yes, Professor.
Okay, so thank you very much for a great talk, John. So I think that many people are interested into the, oh, by the way, so what is that the pop-up window in your
that means I have a meeting that I need to attend in 10 minutes.
Oh,
it's okay.
I see. So everyone is, I think, interested into the GPU talk. So
Yes.
now we are getting into the tri-vendor race or competition by the NVIDIA, AMD, and Intel. So you're
That's
the
right.
last runner, latest runner at this moment. So what do you think that your advantage of the XE or Ponte Vecchio compared with Tesla or MI series?
Well,
Radiant series,
that's a great question, Professor. So what I believe of all the things that I talked about, hopefully I reiterated enough. I think the thing that I'm most excited about is one API, okay? Because I think the industry has been wanting the, what a one API is promising. I'm not saying we're there yet, but the promise of one API is there. And the promise of one API is an open standards, cross-architectural programming model that, because I think we've gone beyond, where that Xeon is going to do everything. Okay, I think the workloads are diverse, and people do not want to leave performance off the table. So I think people are going to be using accelerators more and more. I can tell you the amount of accelerator attached clusters are increasing, not decreasing. So I think one API is probably the most exciting thing. Now, as far as the XE architecture is concerned, we realize we are the #3 GPU. Okay. In fact, when I went to talk to Pete Ungaro at HPC, my HPE, my old boss, he would always tell me, "Hey, John, you're like the 3rd GPU." Okay, it's like, you know what I mean? It's like, how am I going to support you when I need to support the other guys? So, so we have that conversation with him. I have that conversation with him all the time. But I think the key is going to be, are we committed to this architecture? And hopefully I convinced you today that Ponte Vecchio is only an element of our overall XE strategy. Okay, there is a broader market that we're playing with this XE core architecture that we're investing in. So you have to be in the long run. Second thing is, I think what made AMD not as successful as NVIDIA is the focus on software and the programming model. Okay, and as you can see here at Intel, and Joe Curley is going to be talking about the same thing. We are very laser focused on software. We realize that we have to provide means for the developers to be able to reuse code and be able to have the necessary tools and analyzers to be able to make these hardwares performant. And hopefully the work that we have done in the past, and we carry that over to the one API, our developer community would have the tools that they need to be successful. So we're in this for the long run. We realize it. I don't think it's just about the first generation of the Ponte Vecchio. I think where Intel is going to make significant stride is going to be in our 2nd generation, and the 3rd generation follows.
Okay, thank you.
So So in the chat window, so do you see smaller cloud providers doing more for HPC and machine learning? If so, what is of adoption pain point will your strategy address for them?
Oh, that sounds like a really complex question, so I can't see the question. Hold on one second.
Okay.
Let me see if I can get out of this mode and make it easier. Okay, there you go. That worked. Okay, let me get to the chat. Chat. There we go. Do you see smaller cloud providers doing more for HPC and machine learning? If so, what else? What ease of adoption pain points will your strategy address for them? Well, the small cloud providers doing more for HPC and machine learning. Well, if you asked me a couple of years ago, I probably would have said yes. But if you take a look at the major cloud service providers today, and I'm talking about, and inside Intel we refer to them as Super 7, and the Super 7 would be like the Google, AWS, Amazon, and I know I'm missing somebody. There's 4, and then there's Tab, which is Tencent, Alibaba, and Baidu. If you take a look at the 4 major CSP players, they're doubling down on HPC. Okay, and you can tell because of just the people that they've hired recently. Look at the people that they've hired to run the HPC business at the CSPs. Bill Magro, who's our CTO in HPC, our senior our fellow, he is now at Google and responsible for HPC business strategy there. The Nita Chappelle, who used to be one of my peers at Intel, is now the GM responsible for HPC Azure business at Microsoft. So to answer your question, I think it'll be more and more difficult for the smaller cloud providers. Not to say that they don't have a place. I think they're going to need to continue to do something that's differentiated from the major CSPs to be able to be successful. But it is a much more difficult road for them. And in certain cases, the major guys just gobbled them up. Cycle Computing was acquired by Microsoft Azure, for instance, right? And they were a specialist player in the HPC in batch processing. Let me see here. So to answer your questions, we engage with the smaller CSPs as well, but whether they'll be doing more for HPC, I think looking at the engagements that we've had in the past couple of years, I would say the tier 1 CSPs are very engaged and they're very motivated, and they are coming in aggressively to seek HPC customers and win the HPC compute cycles for their cloud instances.
Okay, thank you very much. So it's time to switch to the technical presentations. So thanks again, John Lee.
Thank you so much. I appreciate it. Thank you for inviting me.
Thank you very much.
All right, take care.